Good morning, students. In the last class, we have discussed the MS Excel practicals based on MS Excel practicals related to the random numbers, generation of random numbers, and also fitting of the straight line and parabola by using the principle of least squares method. So in today's class, we'll continue with the next practical, that is practical one fourth practical under this. Third one is fitting of the parabola and exponential curve, which is similar to straight line and parabola. Now we'll see the next practical, that is computation of correlation coefficient and forming the regression lines. In our theory class, we have done a lengthy procedures for these calculation of the correlation and also the regression lines. But here, with some simple functions, we can find the correlation and also the regression lines just by some simple functions. So now computation of correlation coefficient and also the forming of regression lines. First, we'll copy the question. So coming to first question. The first question is, I'll copy the question first. So there is a question. We'll be having two types of variables, right? What are the two types of variables? X and Y. So our X1 will be the dependent variable and another will be the independent variable. So first I'll copy the question. So coming to the question. Coming to question, there are two variable values are given here. So those two variable values, X and Y values are given. So what is generally the correlation? First, I'll find the correlation. What is the formula for correlation? Actually, formula for correlation is covariance of X comma Y. That is covariance of X comma Y divided by sigma X into sigma Y. That is standard deviation of X into standard deviation of Y. So this is the general formula of the correlation, that is covariance of X comma Y divided by standard deviation of X and standard deviation of Y. So in our theory class, we have lengthy procedures for finding this covariance and standard deviation values. But here we just use a simple function. So first I'll find the covariance, that is covariance of X comma Y value. I'm finding covariance of X comma Y value. So I'll find this value here. I've written here. So covariance of X comma Y. So how we write is the formula, the function what we use to find the covariance is always whenever you're writing the formula, you have to type equals to. So equals to, you're finding the covariance. So type COVAR. So COVAR is a function used to find the covariance. Open the bracket. So what do you have here? Covariance of array 1, comma array 2. That means first X values, comma Y values we have to select. So first I'm selecting X values, comma. Now select the array 2, that is Y values. So by simply using covar function, now press enter, we get the covariance value. So this is the covariance value. We got it. Next, I'm finding the sigma x, that is standard deviation of x. Sigma x means that is the standard deviation, right? So standard deviation of x value. So we use a simple function here. I'm using the function, so I'm writing equals to, the formula is STDEV, standard deviation. STDEV is the function. Open the brackets. Now you select, I'm finding the standard deviation of x, so I'll select the x values. Close the bracket. We get the standard deviation of x value. Now similarly, standard deviation of y. Now I find the standard deviation of y by using the same function, that is STDEV, which is equals to STDEV. Open the bracket. Now select all the y values for the standard deviation of y. Close the bracket. Now we get the standard deviation of x. So these are the standard deviations of x, y, and these are the covariances values. So now after getting these values, what is the next step? We have to find the correlation. So now correlation, that is we denote with R, right? R of x comma y is equals to, now I'm finding the correlation. What is the formula for correlation? Covariance of x comma y. Where is the covariance value? This one. Covariance of x comma y divided by, opening the bracket, sigma x into sigma y. So this is sigma x into, this is sigma y. Close the bracket. So in this way we can, one second. First, covariance of x comma y divided by sigma x into sigma y. So this is the R of x comma value. So therefore correlation, what is the correlation value we got? Directly by using simple functions. R of x comma y equals to covariance of x comma y by sigma x into sigma y. So this is the correlation value we got. The value is 0.5390. By this we say that there is a positive correlation between the two variables. So if R value is greater than 0, we say that there is a positive correlation. So this one we got it. Next we find the regression. So first we have two types of regression lines. What are those two types of regression lines? First one is a regression line of y on x. So if I consider the regression line of y on x, so what does it mean? Whenever regression line of y on x is right, what does it mean? That y is, whatever the y value is there, y is dependent variable, and whereas x value is independent variable. So y on x means y value is dependent and x value is independent. So remember this one, that whenever you consider regression line of y on x, y value is dependent and x value is independent. What is the equation we write of the regression line? We write it as y equals to, generally the regression line we write y minus y bar equals to byx into x minus x bar. By simplifying that, it passes to the line x bar and y bar. Actually, what is the regression line we consider? A plus bx. So this is the regression line we consider. In the derivation of the regression line also, first we consider this value only. That is y equals to a plus bx. So this is a regression line of y on x where y is dependent and x is independent. So whenever you consider this regression line, what are a and b? A is called as the intercept, b is called as the slope. So if you want the regression line of y on x, you need a and b values, where a is the intercept value and b is the slope value. So directly by using some functions, we can find out the slope and intercept values. First, slope value I'll find out. What is the slope here? Slope is nothing but b value. So the slope value, that is the b value, is equals to, so to find the slope value, we use the function called slope. So equals to slope of, open the brackets. So if you open the brackets here, you get the format of the formula, that is known y's comma known x. That means first dependent variable values comma independent variable values. So for this, what are the dependent variable y values? Y on x means y are dependent. Select all the y values comma. Now the independent variable, that is x values. So therefore, we get the slope value as 2.2914. Similarly, next I want the intercept. What is the intercept? Intercept is nothing but a value. So intercept a value. In the next cell, I find the value. Here, to find the intercept, I use the function called intercept. Intercept of, open the brackets. Now first dependent variable values, that is y values, comma, independent variable values, that is x values, close the bracket, we get the intercept. So after getting the intercept, what is the equation now I get for regression line of y on x? Y equals to a plus, what is the a value? This a value is 4.8155. A plus b into x. What is the b value we got? B value is 2.2914. So this is the equation of the regression line we get with the simple steps, that is so what is the regression line I got? Y equals to 4.8155 plus 2.2914. Now similarly, now I'll find the regression line of x on y. So if I consider the regression line of x on y, what will be the dependent variable and what will be the independent variable? So first of all, what is the dependent variable? Dependent variable will be x and the independent variable will be y. What is the equation? What is the format of the equation we write? That is x equals to a plus by. So this is the equation of regression line of x on y. So now we have to find the a value and b value, where a is the intercept and b is the slope. So first to find the slope value, slope is nothing but b. We use the function called slope. So slope of, so first what we write, select the dependent variable values. So for regression line of x on y, x is the dependent variable. So you select the x values first, comma. Now the independent variable values, that is y values. We get the slope. Next, similarly, for intercept, which is denoted with a, we use a function called intercept of first dependent variable values, that is x values, comma independent variable values, that are y values, close the bracket. Now what is the equation? The equation is x equals to first a plus bx, right? That is 3532 plus b into x, b into y. So what is the b value? Slope, that is 0.1534 into y. Here I forgot to write x. So these are the two regression lines, that is regression line of y on x and x on y. So it is very simple to calculate the correlation coefficients and also the regression lines in MS Excel. So now next practical, we find the partial and multiple correlation coefficients. Next practical, computation of partial and the multiple correlation coefficients. So before that, you remember the partial and multiple correlation coefficients formulas. So these are the partial and multiple correlation coefficient formulas. So what is a partial correlation coefficient? R12.3. I've written only one formula, that is R12 minus R13 into R23 divided by this R23. R13 into R23 divided by square root of 1 minus R13 square. So I've written 13 into 13 and 1 minus R23 square. So I've written 23 into 23. Similarly, multiple correlation coefficient R12 square plus R13 square minus 2R12, R13, R23 divided by 1 minus R23 square. So I've written 2 times. So now we'll see the problem. First, we'll copy the question. So basically, whatever the problem we have done, we have done different types of problems. So in this, first is, so whenever you are using the data, so in our questions, in theory part also we have done the questions where directly R12, R13 and R23 values were given. But here the values are not given, but we have to find out R12, R13 and R23 first. If you consider R12, what does it mean? R12 means it is the correlation coefficient between x1 and x2. What is R12? R12 is the correlation coefficient between the variables x1 and x2. So how to find the correlation coefficient? We have done before also. By using this procedure, we can find the correlation, or we have a simple shortcut method also. This one you use it for the partial and multiple correlations only. So which is equals to, we have a function called correlate, C-O-R-R-E-L, correl, that is used to find out the correlation directly. So R12 means we are finding the correlation of x1 and x2. So we have to consider first x1 values, comma, then consider x2 values. Close the bracket. We get the R12 value as minus 0.89097081. Next, we find the value of R13. So R13 equals to, use the same function CORREL, that is correl. So first R13, so x1 comma x3 values, we get this value. Next R23, that is equals to CORREL, correl of 2 and 3. So x2 comma select x3 values. We get the 3 correlation coefficient, that is R12, R13 and R23 values. So after getting R12, R13 and 23, you have to calculate the partial and multiple correlation coefficient. First partial, first we'll find the partial correlation coefficients. So for this partial correlation coefficient, what is the first one? I'll calculate the R12.3. R12.3 value I'll calculate. So for this, you consider the formula. So in formula, I have numerator value and also the denominator value. First, I'll find the numerator value separately. Then I'll find the denominator value. What is the formula here of the numerator? So if you see, the formula for the numerator is this one. That's R12 minus R13 into R23. See, R12 minus R13 into R23. So first calculate the numerator for this. For R13, numerator value, that is R12 minus R13 into R23. So this is your numerator value. Similarly, denominator. So in denominator, what we have, check it, square root of 1 minus R13 square into 1 minus R23 square. So here equals to square root of, so here we should use the multiple brackets. First we have written the bracket for square root. Then for first term, that is 1 minus R13 square. So 1 minus of R13 square. So R13, right? R13 into R13. So for square, I'm closing the bracket, and then 1 minus also I'm closing the bracket. Next, what is the formula? 1 minus square root of 1 minus R13 square into 1 minus, again open the bracket, 1 minus, again open the bracket, R23 into R23, close the bracket for square, close the bracket for 1 minus term. Now close the bracket for square root. So this is the, in this way we find the denominator value. So we got the denominator value as 0.0681. So what is the correlation now? This numerator value divided by this denominator value, we get the R12.3 as 0.595. So in the similar way, we can find out the .595. This is the value of R12.3. Similarly, you can find out R23.1 and also R13.2 values. So in this way, we calculate the partial correlation coefficients. Next, coming to multiple correlation coefficients. Coming to the multiple correlation coefficient. Coming to the multiple correlation coefficient, what is the formula? Check out the formula. This is R12.3 square value. So whatever the square value we get, if you apply square root to that, we can get that value. So here, first numerator value we have to write. Next, denominator value. So coming to numerator value, what is numerator? R12 square plus R13 square minus 2 R12, R13 and R23. So first I'll find the numerator value. I'm finding the value of R1.23 square value. I'm finding R1.23 square value. So for this, I'll find the numerator value first. What is the numerator value? Check it. R12 square, R13 square. So first term is R12 square. That is R12 into R12. Next, plus R13 square. So open the brackets. R13 into R13. Next term is minus 2 minus of 2 into R12 into R13 into R23. So in this way we get the numerator value. Now coming to denominator, the denominator what we have? 1 minus R23 square. Denominator value equals to 1 minus R23 square, that is R23 into R23. So we got the denominator also. So now this is equals to numerator value divided by denominator value. This is R square value. Now R 1.23 value will be square root of, we use square root of this value. So therefore R 1.23 value, that is multiple correlation coefficient, R 1.23 value 0.98. So in this way you can calculate the remaining correlation, that is multiple correlation coefficients. That is here I have done R12.3. Similarly, you practice doing R13.2 and R23.1. Here I have done R1.23 value. You find out R2.13 and R3.12. So by this we complete the computation of correlation and forming the regression lines and partial and multiple correlations also. So all the Excel practicals are very important. First is generation of random numbers. So different random numbers we have generated. Next, second one is fitting of straight line and parabola. Third one is fitting of power curve and exponential. I didn't show this power curve and exponential because it is very similar to straight line and parabola. So at adding trend line, for straight line we select linear. For parabola, second degree parabola, we select parabola of degree or order 2. Similarly, at that options only we have power and exponential. So if you want power curve, click on power. If you want exponential curve, click on exponential. Then for straight line and parabola, I have shown you how to fit the trend values also. For parabola and exponential, trend values are not required. If they specify, then only you find out. Otherwise, up to fitting the equations and note down that equation, that will be enough for your practical. So by this, all the MS Excel practicals we have completed. All the 5 MS Excel practicals will be there. All the 5 MS Excel practicals are completed. From this 5, we get any 2 in your exam, you have to write any one. So be prepared for the practical.